So in this function, we will create a feature extraction function. So the function will be doing some steps. So the function will perform following steps. See, first of all, it is going to load the audio file. Load the audio file. Second, it is going to extract 40 MFCC characters. MFCC characters. Third, it will compute the mean across all time frames. Compute mean across all time frames. This is the thing that we had discussed, no? Means the while creating the MFCC, this MFCC characters are created for different time frames, equally divided time frames, and then it will return a fixed length feature vector of size 40. So these are the things that will be happening in it. So let us see how it can be done. One of the what is the approach for it? This I have to select as Python. So def, we will first define a function extract underscore features. Here we will have to pass some parameter. So we are going to pass file path. We need to put a colon here. Done. Now audio comma sample rate. This is the syntax of using Librosa to load the audio. Librosa.load file path. Clear? The file path, the function will get the file path as a parameter, as an argument, and it will load the audio file using that file path. Okay. Then MFCCs. What is the MFCCs? Librosa.feature.mfcc. Librosa.feature.mfcc. Here we have to specify audio, sample rate, and we have to give the number of coefficients. We want 40. Okay. Now we have to scale it. So MFCCs underscore scaled equals to np.mean. Exactly the same thing that we had practiced in the last video. np.mean MFCC dot t comma axis is equals to 0. And finally, it has to return. This will also come in definition only. Return. What will it return? Scaled MFCC. Copy and paste it here. Let us see if you are okay. No error. So the function has been defined successfully. Let us check it. We are already having one audio path that we had described in this code, right? Here, see, audio path we had made. Let us see whether it is working this, whether it is giving the same result using the function that we have just defined. So features equals to extract underscore features, and I have to give the path. Let us see what is the features. Features is not defined. Why is it not defined? Because I have FEAT features. Okay. See, so we are getting it. I'm getting an array. Let us see the shape. This is 40. So it is working successfully. So let's go ahead. Now, let us just see metadata once. Metadata. Okay. See the slice name, fold, class ID, fold. So to create a path, I need slice name and fold, right? So we have to understand these things. So let us first, means I have already created my definition. Now, first what we do generally in the practical projects, we first test our this function on a small sample. And then when it is successful, we apply it on the whole project. Okay. There is a reason for it. For example, like here, if we apply on the whole sample, no, it will take time. So if there is some error, first we, means if we compile it, it will be difficult to debug. So that is why we do it on a small, yeah, small sample. Okay. So let us go ahead with it. Testing feature extraction on a small sample. So let us see how it is done. For index, comma, row in metadata dot head dot iter rows. Here file path is same thing, similar to what we have done previously. First of all, the path, I will simply copy this and I will remove one from here because I only want till fold. 1, 2, 3, 4, that will be decided by the other one. Okay. So this one, no, plus. Now this is interesting. I need the fold number. Where will I get the fold number? This is the fold. So plus str of row of fold. Now here plus we have to put backslash 2 times. And again I have to put the name of this file name, right? Plus row of slice file name. So this will do it for 5 rows. We are doing it for 5 rows. Okay. For loop is running. File path has been defined. Now data equals to extract underscore features file path. This file path, notice that it is in the loop and it is getting changed with every loop. Now we have to save it. So extracted extracted features dot append. Prior to this, we have to assign it as an empty list. Okay. Now dot append. What I do want to append into it? I want to append data. So I will append the data. Along with this, I have to give the class also. Row of class. Means which class it belongs to. And let us finally, outside the loop, just to check it, print total processed files are, comma, length of extracted features. So we are ready to run. Let us see if our for loop is correct or not. Data frame does not have iter rows. Okay. Append takes two arguments. Exactly one argument, 2 was given to append. Let me see. Data comma role. Feature dot append. Okay. I think I am facing this error because I have to give this as a list here. See, data, not SATA data. And here also I have to put a, now it should work. See, it has worked. And total processes files are, total processed files, simply some corrections, are 5. Since I have since I ran the loop twice, now it has become 10. Okay. So our function is working. My for loop is also working. Let me see how it looks in a data frame. So features underscore df is equals to pd dot data frame. Simply I'll pass this one. And I need to specify the columns also. Columns equals to, I want to name the columns as feature, comma, class. Invalid syntax. Because I need to put this as like this. Wait a second. Now it should be pandas as no. Why? Because F has to be capital. No. D also has to be supposed to be capital only. Let me see. Feature is not defined. Feature is not defined. I think it has to be feature. Where is feature? This has to be put into, because this is the name that we are specifying, na? So we had to put it into double quotes. That mistake I was doing. Okay. So features underscore df. Wow, we got a data frame, right? And there are total 10 entries. We can see the 10 entries. And the features it is having, this is a list of 40 coefficients, 40 MFCC coefficients. So we have successfully created a data frame on the sample rows. Okay. So now we will apply it on the entire data set. Applying the, or rather, feature extraction on the entire data set. This we have to do now. So let us see how we can do that. For this, we will import a TQDM. This will show me the this task bar, sorry, completion bar. Okay. From TQDM, import TQDM. Now, let us see. I need to define an empty set. Features, here I had used extracted features. Extracted features. Something happened. Sorry, yeah. Extracted features. This is an empty set. See, I have used the same name because when I define it here, now again it will be assigned to an empty set only here. So I can use it again. Okay. Now let us see. For, I don't need the index, so I'll leave it blank, comma row. In TQDM of metadata dot iter rows, comma, total equals to length of metadata. Now look carefully in this code. For row, basically it is for row in metadata.iter rows. Okay. This TQDM, this total length of metadata why we have used, so that one completion bar, one progress bar will come when we are executing it. This progress bar is very essential when we are working with a large data set to know whether means our task is completed or how much percentage is completed. So to know the percentage, for that we have given this parameter. So this is for TQDM basically. For loop uses only this one and this one. Okay. We don't want to generate. Okay. Now, so the loop has been defined. Now, file path. File path is equals to colon start R. Again, I have to give the path till fold. This is the third time we are doing. The more you do, the more you will be practiced in this. I don't want fold 1 because the fold number will be picked up from plus. Now, str of row of fold. From here I got the fold number and I have to put double slash also. And final row of what I want here, the slice name, slice file name. Okay. So here it has created the file path. Now data is equals to extract underscore features, which is the name of my function, and here I have to pass file path. So all the files will be loaded here now, and then I have to update it in the list. Extracted features, not extract, rather extracted features, which is my empty list, dot append. What I have to append? I have to append two things here. Data, comma, row of class. There seems to have been some issues are there. Let me see. I think this should be fine. Comma, row of class. Okay, I think this should be fine. One more has to be there. Why is this showing as an error? Okay, we'll see. So extracted features, I think we have done it. So we can go ahead and execute our code. Clearly, it is going into the loop. TQDM is a new functionality that we are adding just for the convenience, for presentation purpose. Data is being extracted in this function, and the extracted features are put into the this loop. Sorry, in this empty list. Later, we will convert it into this data frame. Detected at line. Undetermined string literal detected at line 9. Okay. I think some mistakes are there. I think data should not be here. No, this is correct actually. Let me check it. Okay, yeah, this one, this code should not be there. Okay, now I think we are good. Unicode error. Generally, Unicode error comes when I'm not putting this R properly, but I have put the R here. I don't think this error should come. Let me check it. Unicode shape. Okay, I found my mistake here. This R has to be inside this and not outside. Okay, that is why it was happening. Okay, see, so it is working, it seems. And I think we should get the progress bar also. Yeah, yes, progress bar is working. So let us wait for it to complete. I will just pause it for a few seconds because since it is a large data set, it is about 6 GB long, it is bound to take some time. Okay. So I'll just pause it for now. Once it is done, we'll see. Okay, so it took some time, but it is completed now. As you can see, it has reached 100%. It took 7 minutes and 11 seconds. Okay. So, of course, the data set was long. It was bound to take some time. So now we'll create the final data set. Okay. So, creating the final data set. Let us see how we can do that. So, I have features equals to pd.dataframe. I'll put it as features underscore df pd.dataframe extracted features. This was my extracted features, right? See, one more thing, I can check the size of it, whether to see it was completed properly or not. Just dot shape. Okay, at shape it is not working. So 8742. You remember in the starting that there were these many entries in it. So it seems to have worked. No. Something wrong has happened. Okay. Here, something wrong has happened. When I mentioned here that we can use it, so I was wrong here. You cannot use it. I have to change this name. Okay. 10 extra features have been added in my data frame. So this is one conceptual mistake that I have done here. That is why I am having 10 more data points compared to previous one. It was supposed to be 8732. Okay. So we get a new lesson. This cannot be used directly. So extracted features list. I'll put it like this. Underscore list. Unfortunately, now I have to run it again. So that just to avoid confusion, we'll do this only. Okay, we'll run it again. Other option is that in this data frame, we know that the top 10 values are from the previous list. So we can drop the top 5 columns. Sorry, top 5 rows. Okay, top 10 rows. That is also possible, but let us not, because that is only for this situation. We'll run it again. Why it is not defined? Because this has not been executed. Okay, it will take some time, but after this is done, we'll have a look at it. Okay, so it is done now. So now we'll work here on creating the final data set. Okay, so extracted features list. I have changed the name of the list which is 8732, which is the correct value. Okay, I made that mistake there. So yeah, now features underscore df, I have to see convert it into data frame, right? So first of all, I have to put this here, what I want to convert into data frame, and the columns. I have to give the columns. So columns will contain features. Means column is the column name actually, what I want the column name to be, and class. Let us go ahead with it. So is it completed? We can always check it. Okay, so it is done. I have my features, I have my class. Okay. So we will pause for this video now. Now the next step is our separating our features and labels and then train test split. Those things are there. So I do hope that you understood this part. It is a very interesting thing, is the thing that we have done here. Do let me know if you have any doubt. We will certainly have a look at it. Thank you.